Hello everyone, how to solve this problem for the values of k if we have k square divided by square root of k is equals to k, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods. But if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. And here in the first method, we move this square root of k from left hand side to the right hand side. It is divided by here. When we move it into the right hand side, it is multiplied by this k. And after moving this to the right hand side, it will be written as k square is equals to k times of square root of k. So here our target is to find the values of k. So that's why here we need to remove this square root sign from right hand side. So in order to remove the square root sign, we need to take squaring on both of the sides, so that when we apply squaring on both of the sides, it will be written as k square and its whole square is equals to k times of square root of k and its whole square. So further here in the next step, you see that this is k square and its whole square becomes k to the power of 4 is equals to, in the right hand side we apply the square separately on both of these two values, and it will becomes k square multiplied by square root of k and its whole square. And now here further in the next step we have this is k to the power of 4 is equals to, here we have k square. These 2 and this square root are cancelled out by each other, and here we get only k. And now here we need more simplifications, and it will be written as k to the power of 4. This is k square multiplied by k becomes k cubed, and it is lies into the right hand side, so we move it into the left hand side and it will becomes minus k cubed, and this whole equation is equals to 0. And now you see here both of these two terms involve k cubed, so that we take common k cubed from here, and when we take common k cubed we get the remaining values are, from here we get k only, minus from here we get 1, and this whole equation is equals to 0. So you see here we divide this equation into the two cases. The first case is we write k cubed equals to 0, and the second case is we write k minus 1 equals to 0. From here we easily get the value of k is equals to 0, 0 and 0, because this is a cubic equation or third order equation. It means that our k is equals to 3 times of 0. Okay, these are the three roots of the given equation, and from here we get the fourth root of the given equation. So we move this minus 1 to the right hand side and we get the value of k is equals to plus 1. So this is the fourth root of the given equation. So here we have these are the four roots of the given equation which we get here in the first method. And now here in the next step we need to verify that is these values of k be the solution of given equation, or is these values of k be the extraneous root. Okay, so moving to our second method, first we need to verify these roots. Okay, for verification we need to copy down given question statement. Here it is k square divided by square root of k is equals to k only, and here in this side we will be verify k equals to 0, and in this side we will be verify k is equals to 1. So here first we substitute k equals to 0 into the given question statement, and after substituting this it will be written as, so when you put it here it will becomes 0 square divided by square root of 0 is equals to 0. Okay, so here you see that 0 square becomes 0 and square root of 0 is also 0 equals to 0. So here we know about that 0 over 0 form is usually called that it is the indeterminate form. So if this is the indeterminate form, or in other words we just say that it is undefined. So if our left hand side is undefined, this means that both of the sides are not equal. So if both of the sides are not equal, we conclude about that k equals to 0 is not the solution of the given equation. So we call that k equals to 0 be the extraneous root of the given equation. Okay, so This is the extraneous root because it does not satisfy our given question statement. And here further we move towards our second solution. So we put k equals to 1 into the given question statement, and it will be written as 1 square divided by square root of 1 is equals to 1. So 1 square becomes here 1 divided by 1 is equals to 1, and here this shows that 1 equals to 1. This means that both of the sides are equal. So if both of the sides are equal, we conclude that k equals to 1 be the solution set of the given equation because it is satisfied our given question statement. So from first method, this is the final solution of this problem. And now here we move towards our second method. And in second method, here first we need to copy down a given question statement here, so that our given question statement is we have k square divided by square root of k is equals to k. This is our given question statement, and now here we again solve this problem for second method. So our second method be the very quickest method, and here we quickly get the values of k. So first we break this k square as, we write k square as k multiplied by k, and it is divided by square root of k is equals to k. And further in the next step, we again rewrite this equation as this is our k, and we write k as square root of k multiplied by square root of k, and this is again our k divided by square root of k. You know that when square root of k is multiplied by square root of k, the square root are cancelled by each other and we get only k. Okay, so we write this k into the form of product of two square root terms. Okay, so here in the right hand side we have k only. So you see that this square root of k and this square root of k are cancelled out by each other, and from here we will obtain k times of square root of k is equals to k. So here we need more simplifications, and now here we need to take squaring on both of the sides. So here when we apply squaring on both of the sides, it will be written as in this form. And now we apply the square separately on both of these two values, and it will becomes k square into square root of k and its whole square is equals to k square. And further in the next step, these 2 and square root are gone, and we will get here k square is multiplied by k equals to k square, and this k square times k becomes k cubed, and this k square becomes minus k square, and this whole equation is equals to 0. And now here we need to take common k square, and when we take common k square, we get the remaining values are k minus 1, and this whole equation is equals to 0. And here we divide this equation into the two cases. The first case is k square equals to 0, and the second case is k minus 1 equals to 0. From here we get the values of k are 0, 0, and from here we get the values of k are 1. So in the second method we get these are the three roots of the given equation, but in the first method we already verified that k equals to 0 is not satisfied our given question statement. So we call that this is the extraneous root of the given equation, and you see that k equals to 1 is satisfied our given question statement, so we call that it is the solution set. Okay, so finally we have k equals to 1 be the solution set, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.